Good evening, everyone. Our topic for the day is mean deviation. The topic for the day is mean deviation. So, today we will study the concept of deviation of a set of data from its mean. So, for example, first let us take the definition, then we'll come to an example maybe. The mean of the absolute values of numerical differences between the numbers of a set. By a set over here we mean a set of statistical data over the mean and the median is called the mean deviation. So the mean of the absolute values means the modulus values of the numerical differences between a number and its mean or a median. This term is called the mean deviation. Let us try and understand with the help of an example. Before that, we need to understand mean deviation can be calculated either about mean or about median. So we can calculate mean deviation about mean and we can calculate the mean deviation about a median. Okay. So the definition of mean deviation about mean would be the arithmetic mean of the numerical deviations of the observations from a mean of the statistical data is called the mean deviation about mean. It might be slightly confusing because of the nomenclature. It is the mean deviation about the mean, but when we do an example, it will probably sound a little bit simpler. The next topic or the next kind of mean deviation is mean deviation about a median. So for this, we need to calculate the median of the data and then calculate the mean of the deviations from that median. Any questions so far? Okay. So let us take the formula for mean deviation about mean and the formula for mean deviation about the median. So assuming that the mean is represented by x bar, then the formula for mean deviation would be summation represented by sigma modulus of xi negative mean, the entire summation divided by number of observations. Similarly, the mean deviation about the median would be summation of absolute values of each numerical value difference the median, entire thing over the number of observations. Okay, so let us take this with the help of an example. Now we need to calculate the mean deviation about mean for the numbers which are on the screen 2, 4, 7, 8, 9. So we have 5 numbers 2, 4, 7, 8, 9. If we calculate the mean of these 5 numbers, the formula, if you remember, for calculating the mean is summation x divided by number of observations. So that would be 2 plus 4 plus 7 plus 8 plus 9 divided by 5, that comes out to be 6. So the important thing is that the mean comes out to be 6. Now, the next step is, since the mean comes out to be 6, we'll populate another column which will be x negative mean, and we need to take the modulus of that. We call it d. So x negative mean, so it would mean 2 for the first row, it would mean 2 negative 6, that is minus 4 within modulus, so means plus 4. For the next row, it would mean 4 negative 6 within modulus, so it will be equal to 2. Similarly, 7 negative 6 within modulus, so that will be equal to 1. Does it make sense? Next one would be 8 negative 6, that would be 2 within modulus, so that's equal to 2. Similarly, 9 negative 6, 3 modulus 3 is 3. When we sum these numbers up, we get 4 plus 2, 6 plus 1, 7 plus 2, 9 plus 3, 12. So 12 is the sum of the deviations. Now that 12 divided by number of observations, which is 5, gives us 2.4. Hope this makes sense to everyone. Does anybody have any queries? Feel free to ask questions. Okay, so let us move on to the next slide. Let us calculate the mean deviation about median for the observations 2, 4, 7, 8 and 9. Step 1 would be to calculate the median. In order to calculate the median, we need to arrange the numbers in ascending order. So they are already in ascending order, 2, 4, 7, 8 and 9. The middle number would be the third number because we have 5 observations. So 7 is the answer for the median. Now, once we know the value of the median, which is equal to 7, we need to calculate the mean deviation about 7, which is the median. So step 1 would be to calculate x negative median of x. Now median of x is 7, so 2 negative 7 is negative 5. Negative 5 within modulus is positive 5. So 2 negative 7 would be negative 5. Negative 5 taken over modulus gives us 5. Similarly, 4 negative 7 gives us negative 3. Negative 3 modulus gives us positive 3. 7 negative 7 is 0. 8 negative 7 is 1. Modulus of 1 gives us 1. And similarly, this comes out to be 2. On adding these numerical values, we get 11. So the mean deviation about median would be the summation of the deviations, which is 11, over number of observations, which is 5. So my final answer would be 2 decimal 2. Any queries, anyone? Okay, let's move on to the next slide. Further, we need to know what is the mean deviation for discrete frequency distributions. So the mean deviation about the mean has the following formula as on the screen. It is the summation of frequency times modulus of observations negative mean, entire thing divided by the sum total of the frequencies. So let us take an example. In this data set, we'll realize that the value of x, that is the size, is given in the first column and the value of frequency is given in the second column. Now we can easily calculate f multiplied by x, which is our column number 3. On summing it up, we get 160 divided by sum total of the frequencies, which is 20, we get 8. That gives us the value of mean. So our value of mean is equal to 8. Now, why do we need to calculate mean? Because this question asks us to find out the value of mean deviation about the mean. So the step 1 would be to calculate the mean. The value of mean comes out to be 8. Once we get the value of mean, we need to further calculate the value of mean deviation about this mean. The process hereafter remains the same. Once we have found out the value of mean, every time there is a value of x, we need to subtract mean from that. So 2 negative 6 would give me negative 8. My bad. 2 negative 8 would give me negative 6. 2 negative 8 would give negative 6. So modulus of that would give me 6. Similarly, 4 negative 8 would give me negative 4. Modulus of that would come out to be 4. Similarly, we get 6 negative 8 is negative 2. Modulus of that gives us 2. And finally, we get all the set of values for the modulus of deviation. After finding the modulus of deviation, we need to calculate frequency times the modulus of differentiation. Frequency times the modulus of deviation. So 6 times 2 would give me 12. 2 times 4 would give me 8. 4 times 2 would give me 8. 5 times 0 would be 0. 3 times 2 would give me 6, and so on. 2 times 4 would be 8. 1 times 6 would be 6, and 1 times 8 would be 8. This is how we calculate frequency times the modulus of deviation. Once we get that value, we need to sum it up. We find it comes out to be 56. After getting the value of 56, our job is to calculate the mean deviation about the mean. The formula is 56 over the sum total of frequency, which is 20. Comes out to be 2.8. Any questions, anyone? Okay. So next we'll take up an example of mean deviation about the median. So this is mean deviation about the median. Here we are given the values of x and the values of frequency. So the step 1 would be to calculate median. In order to do so, we first need to calculate the cumulative frequency. If you remember, we have discussed this in details in our class on median. So the value of cumulative frequency would be, for the first row it is 3, for the second row 3 plus 4 is 7, then 7 plus 5 is 12, 12 plus 2 is 14, 14 plus 4 is 18, and so on. The cumulative frequencies last value comes out to be 30. This is also the sum total of the frequencies. Now, since 30 is an even number, we divide it by 2, we get 15. Median is the mean of n by 2th term and the next term. So the average of the 15th term and the 16th term, which basically coincides with 13. So our answer for the median in this question is 13. Okay. So if this part is clear, we'll take you to the next page, the next slide, where we'll discuss in details how to calculate the mean deviation about median. So now we have the values of x in column 1, the value of frequency in column 2. The third column would be the value of x negative the value of median. So if you remember, our median was 13. 13 was the median. So once we know the median, we need to subtract 13 from each and every one of the values of x. So 3 negative 13, 6 negative 13, 9 negative 13, and so on. On getting this, we take the modulus of these numbers. We get 10, 7, 4, 1, 0, 2, 8, and 9. Multiply this with frequency to get the next column. Let me know if you have any questions. So the value of the mean deviation about median would be 149 divided by 30. So that is the last column, the total of the last column divided by the total of the second column. 149 divided by 30, that is 4.97. If that is clear, let us take up a very interesting question. This is the mean deviation about mean for a continuous frequency distribution data. So in this question, we have been given the class intervals or the class boundaries and the frequencies. We first need to calculate the mean followed by the mean deviation about the mean. So if you remember, in order to calculate the mean, we first need to calculate the mid value, which is the average of 10 and 20, average of 20 and 30. So we get column number 3. In that column number 3, we are using the step deviation method. In column number 3, the fourth row, the value in the fourth row, which is 45, is taken to be the assumed mean. It is taken to be the assumed mean, that is 45. Assumed mean is 45 in this question. Now, every time you get a value of x, subtract the assumed mean from it to get the next column. So 15, negative 45, 25, negative 45, 35, negative 45, and so on. Remember, this time we do not take the modulus, so this is just simple difference, not the modulus difference. So minus 10, minus 30, minus 20, minus 10, 0, 10, 20, 30 are the values of deviation, x minus a. Now this number divided by the class interval is 10, the difference between 20 and 10, difference between 30 and 20. So on dividing by 10, we get negative 3, negative 2, negative 1, 0, 1, 2, 3. Now to get the last column, we need to multiply f with d. Multiply f and d. We would get the last column. We can also find the total of the last column from the same using the calculation. So the formula for mean would be assumed mean plus class interval times summation fd by summation f. So my final value comes out to be 45. So the mean for this set of data is 45. Now, once we have calculated the mean, we need to calculate the mean deviation about the mean. In order to do so, we already know the first column, we know the second column, we also know the third column. We have found out x negative mean of x. So far, so good. We need to multiply this with the frequency. On multiplying this with frequency, we get the last column in this table. The total of this last column is 400. So the value of mean deviation would be this 400 divided by number of observations, which is 10. This is how we calculate the mean deviation about mean. Is that clear for everyone? Okay. Feel free to ask any questions if you have. Okay then. Thank you everyone. Have a good day. See you.